Hello everyone, welcome to Legacy IAS. So this is based on a very simple intuitive question that why don't satellites fall on Earth? Now, for some people it may seem very natural that why something, for example, if I throw this pen up, it comes down, correct? That is, it goes towards the center of the Earth, that we understand. Now, if satellites are also going away from the Earth, if this is Earth, okay, if satellites, if I throw something here, it falls back here, correct? As you saw with this pen. Then why don't satellite also, which are let's say located far off, but shouldn't they just fall like this towards the center, correct? Because the gravitational pull is like this only, na? Gravitational pull between two objects is along this line, correct? So it must be pulled like this, but it does not fall back on Earth. Now, why it does not is the question. You understood the question? Now, so basically, there are three games that we need to understand to really understand why don't satellites fall on Earth. Now, the first is this path versus velocity game. Now, what is this? See, if this is Earth, now this is me. Now, I throw a ball like this. I throw a ball like this horizontally. Now, what will happen? The ball will fall somewhere here like this, correct? If I throw it like this, now let's say I go to gym, I make some more muscles and everything, so then I can throw and it can go like this, correct? Much far off. Now if there is somebody who is very powerful, he can even throw it like this and it can come here. Somebody can even throw it like this such that it falls on the other side but still falling on Earth. But if I just keep on continuing in the same way, can you see that at some point this can be thrown at a velocity that it tries but it just never falls back on Earth, correct? And this is what you get as orbital. So what you are seeing here is basically this. Can you see now? So basically this is still trying to fall on Earth, but somehow it has enough pace that it is able to complete the entire circle. So from here to eventually you can get a point that directly takes it from here to here. This is the path versus velocity game. So it is all dependent on velocity, that at what speed you are sending it out from the Earth surface. Then let's see another game. This is fall versus altitude game. Now understand this. So basically, if this is Earth, now you understand that there is a satellite like this. Now this satellite is going. Now don't you think that if it has a velocity in this direction, correct? If it has a velocity in the horizontal direction like this, now Earth's gravitation is actually pulling it, if there was no Earth or no gravitation, which path it will follow? It will follow this path and it will keep on going like this. But because there is Earth which is pulling it constantly, that is why it falls by this distance. Can you feel this? It had a velocity here, but every time it is falling by this distance towards the Earth. Every time. Here also it has velocity like this, correct? In the direction like this. Now again it is falling this much. So actually the satellite is falling every time, but the fall is such that the altitude from the Earth does not change. So from the center of the Earth, if you look at, so this distance is equal to this distance is equal to this distance. Now, if all these distances are equal, what will the path be called? What will be the path be called? Eventually, if all these distances are equal, that means it will form a circle. That is what we know as circular orbits. So you understood what is happening here? That every time it is falling, in fact, but it is falling only till a distance such that the altitude that it had with the Earth is not decreasing. If it starts decreasing, then at some point of time it will eventually fall. But altitude is actually constant here. Understood? So this is the fall versus altitude game. And last, is orbital distance and orbital velocity. This will make you understand why the orbits that are closer to Earth behave differently from the orbits that are far from Earth. Now see, now don't you think that if there is a satellite here and it is going in this direction, correct? Now it has to fall actually much larger distance, correct? While it has to fall this much distance, it should be allowed. Why larger distance it must fall? Because gravitational pull at this point 1 versus at point 2, where will be the gravitational force will be higher? You tell me this. Where the gravitational force will be higher? At 1 will be higher, correct? Because this is closer from the center of the earth, so it is closer from the center of the earth. That means gravitational force here will be higher. Now if it is higher, that means the fall that you have here, will also be higher, correct? That means a satellite that is in this orbit must be traveling very fast. Then only it will be able to provide more space for this fall, because fall has to happen. So here let's say the fall happens of around 500 meters. Then at this point, the amount of fall that is needed, let's say at this point, the amount of fall that is needed will hardly be 200 meters. Why? Because gravitational force is not that high, so it is not being pulled by the same force. So here I only need a buffer of 200 meters. Here I need a buffer of 500 meters. And how can I get that buffer? How am I getting that buffer? Because of this velocity. And that is why the velocity here at 1 must be higher, and the velocity at 2 will be much lesser than this. Now from this you see what? That as orbital distance. What is orbital distance? So these are orbits, these parts around the earth, these are orbits. Now if you see here, this orbit is much closer, correct? And this orbit is much farther. So the closer orbit, orbital distance and orbital velocity are inversely related. Now I'm not writing the exact term, okay, that we'll see some other day. Right now you only understand what? That if something is closer, it has to, because the gravitational pull is higher, it has to manage much higher fall, and that's why the orbital velocity has to be much higher. Understood? That is how you get this difference between orbital velocity and orbital distance. That's it. I hope you understood the fundamental question that we started with. Why don't satellites fall on Earth? In fact, they do. In fact, they do. They do fall. They do fall. Try to fall back on Earth. But the velocity that they have is actually carrying them forward much faster. So so that is why I'm telling this is like a game. So it is falling towards Earth, but the velocity is much higher, or velocity is high enough to keep it moving forward, and that's why it keeps falling, it keeps moving, and it forms a path. That is it. Thank you.